We have to obtain the value of r such that it satisfies the given equation where a and b are constant vector. So let's begin. We are provided with an equation, the second derivative of vector r with respect to t. So that's equals to the constant vector a multiplied to t plus vector b. So b is also a constant vector. What we'll do, we'll take its integration both sides with respect to t. So that means we'll multiply it with dt. So this will be equals to integration of vector a times t plus vector b integrated with respect to t. The integrations of the second derivative of r with respect to t, so that simply equals to the first derivative of r with respect to t. So this will be equals to a vector being a constant, so we have a vector times integration of t dt plus b vector, which is a constant, so that's multiplied to integration of dt. That gives us first derivative of r with respect to t, so that's equals to a vector times integration of t dt, so that's 1 over 2 t squared plus b vector times integration of dt, that will be simply t plus a constant of integration, so let's call it c1. Now c1 must be a vector. That's because on the left hand side we have dr vector over dt, so that's a vector quantity, and on the right hand side we should also have a vector for the equality to hold. The first term is a vector. Here we have a vector a multiplied to some scalar t squared over 2. Second term is also a vector. We have a vector b multiplied to the scalar t. So that means our third term, which is c1, must be a vector in order for this particular equation to hold. So let's call it equation number 1. But we are asked to find out the value of r. So that means we have the first derivative of r with respect to t. What we'll do, we'll again take the integration on both sides of respect to t. So that means we multiply it to dt. And this will be equals to, so we have a vector over 2, so that's a constant. So this will be multiplied to integration of t squared dt. Plus we have b vector multiplied to integration of t dt. Plus c1 vector multiplied to integration of dt. The integration of dr vector over dt, so that will be equals to vector r, which will be equals to a vector over 2 integration of t squared, so that will be 1/3 t cubed plus vector b multiplied to half t squared plus c1 vector multiplied to integration of dt, so that's simply t. So we will get another constant of integration, which will be c2 vector. That means we have our final result. So our vector r, which is a function of the parameter t, so that will be equals to 1/6 of t cubed times vector a plus half t squared of vector b plus c1 vector times t plus c2 vector. So this is the value of our given vector valued function r.